again, just so we can put it up here to refer to. Protons and, okay, so protons and neutrons, right? Now, and it's in an atom. I'm not going to write that up here at the moment since we're just going to use this for reference. An atomic number is what? Number of protons. Now, yesterday at the end of class, because we said that atomic mass was was the number of protons and the number of neutrons, which of those numbers had to be bigger? The one that was 2 particles or the one that was 1 particle? The 2 particles, okay? So the atomic mass is always going to be your bigger number, okay? It's always going to be the bigger number. Now, the atomic number is always going to be the smaller number, okay? So for those of you who were absent yesterday, we wrote this down yesterday, okay? Everybody got it? Do I need to wait, Bree? Okay, tell me when you have it. Because I know Alexis was still testing yesterday, and there are 2 or 3 of you who are out. Now, this is probably one of the most important things we'll write down today, other than one thing I'm going to add to this. But I'm going to go to the next slide for a minute to point something out. Logan, get off that phone, or it's going to be up here on my desk for the rest of the class period. Okay. So yesterday at the end of class, we were looking at this block that I had clipped out of somebody's periodic table. And I told you the periodic table that you see up there and over there are exactly backwards from each other. The one that's over there is like the one that's on the board, and the one that's over here is opposite it. That one I got from a book company from somebody who I used to teach with. He was the principal at the middle school, and I taught his kids. And this one I ordered from a science company. Now, when you look at these, one of them's the atomic number, one of them's the atomic mass. And some of you are going to get them backwards all the time, okay? So that's why I gave you these clues. The one that's the bigger number is always the what? The mass. The one that's the smaller number is always the what? The number, okay? So when you look at this, it doesn't matter who's on the top and who's on the bottom. The one that's the small number is always the atomic number because it's the smaller of the 2 numbers. The one that's on the bottom is always the bigger number, so it's always going to be the atomic mass because it's the larger of the 2 numbers. All right, so we remember that from yesterday, correct? All right, now, we have not talked about electrons. All right, we have these 2 numbers up here, but nothing about electrons. There's no number that says electrons, right? So how are we going to find electrons? Does anybody remember from middle school where electrons come from? Okay, the subtracting, hold that thought. We're going to get to subtracting. It's not electrons. Something else. Anybody know anything about electrons? Okay. An atom is electrically neutral, which means it has no charge. So, if an atom is electrically neutral, it can have no charge whatsoever. What does that mean for our protons and our electrons? If it can have no charge, do they have to be the same or do they have to be different? They have to be the same. Okay? So if the atom has to have the same protons and electrons, the number of protons equal the number of electrons. All right, the number of protons have to equal the number of electrons. Caught up? All right, so let's talk about how we're going to do this. Everybody there? Or do I need to wait? All right, so how are we going to find protons in an atom? How are we going to find the protons? Write the question down. And then I'm going to go back if you don't remember. All right, if I go back, because you're going to have to be able to do this on your own. Everybody's going to have their own element on Thursday. You're going to find your own protons. I'm not going to tell you. You're going to have to be able to find it. We're going to practice this today. We're going to practice it again a little bit tomorrow. Thursday, you're on your own. How do you find the protons? What on the board up here tells you your protons? That's right. Okay? So, how do we find protons? The atomic number. Okay? Your atomic number tells you your number of protons. Now, how did I tell you you could find your atomic number if you didn't know it? It's the little number or the small number. Okay? Okay? You got to find your electrons. How are you going to find your electrons? Hang on 1 second. I'll write the question, then I'll ask you. Hang on. I'll write the question. What? All right, so if we look at back here for those people who didn't yell out an answer immediately, how are we going to find our electrons? What did you say, William? Okay.
So the mass.
Mm-hmm. All right. I heard one answer up here. I heard an answer back there. What did you say, Sierra? Okay. So, two different answers I got. Both of them are the same. All right. They're the same as the protons. Or you can write the same as the atomic number. Now, notice I wrote same as the atomic number. Is atomic number defined as electrons? No. Okay? So if you write down atomic number is the number of electrons, the definition is wrong, you're going to have the wrong answer. Okay? Atomic number is defined as the number of protons. You got to be careful about that, which is why I wrote it's the same as atomic number and not just the atomic number. All right? Now, the last one we've not talked about. Okay? We got to find the number of neutrons. Okay? And that's why I said to Alizé to hold that thought, because she had said subtract a minute ago also. All right? And this is usually the one that people remember from middle school. Because y'all remember doing this in middle school. Okay? We're going to find the neutrons. And this is why William yelled subtract from the back. Because this is the one that requires us to subtract. So when y'all all said, well, we got to do a little more math. Well, technically, yes, but it's only subtraction. I don't consider that more math because you're not using any kind of formulas. Okay? You have a calculator because you're going to subtract. All right? Now, we know I don't like that color. That atomic mass is protons plus neutrons, right? And we know atomic number equals protons. So if we want just the neutrons, how do we get those protons to cancel out? That's right. So we're going to subtract these two things. We're going to subtract them, and these protons are going to cancel out. Okay? That's why we subtract atomic mass minus number. Okay? Does that make sense? Because we need the protons to cancel out. So we always say atomic mass subtract atomic number. All right, but the reason we do it is to get those protons to cancel out. Mass minus number. And that'll give us our number of neutrons. Questions about how we're going to do those three things? Everybody got them written down? Because on Thursday, when you come to me and say, Miss Paul, how do I? I'm going to say, look in your notes. Ask somebody at your counter. I will not tell you. Okay? Somebody's going to need to take Caleb under their wings over there, by the way. Sacramento, at least, I think will be okay. All right, everybody got it? All right. Now, this is one of two notations you have to be able to use. Odds are good. In middle school, you never saw either of these notations. Your teacher probably just, and hang on a second, don't get mad, probably just used this, and you found protons, neutrons, and electrons, and you rounded off the periodic table. Perhaps not right. All right? You have to use one of two notations. This one is called nuclear symbol notation because you have the nuclear symbol. P is the nuclear symbol of phosphorus, okay? Students generally like this notation because both numbers are given. It's not my favorite one to use simply because it's a pain in the rumpus to have to type, okay? It's a pain to type. The students like it because both numbers are given to you. We want to be able to find protons, neutrons, and electrons given that notation. Now, what is the 31? Oops, too far. Is it the mass or is it the number? It's the mass because it's the what? It's the big number. Okay, so that's the mass. The 15 is the what then? It's the number. Okay, everybody see how we did that? Big number is mass, smaller number is number. All right, now we're going to use what you guys just told me and we just wrote down. How do we find the protons? Protons are the what? Atomic number. So we're going to look right here with what y'all just told me. You said the big number was the mass. The little number is the atomic number. Okay? So, the protons. What did you just tell me the protons are? The protons are the atomic number. Which number is the atomic number? Okay. So protons, you just told me, are the atomic number. Your atomic number is 15. Everybody okay with that? Yes or no? Yeah? All right. So electrons. What did you tell me we did to find electrons? They're same as the protons. Okay, so same as protons. So how many electrons are there? There's 15. All right, neutrons. How do we find the neutrons? What do we do to find neutrons? We subtract what minus what? The mass minus the number. All right, what's my mass? What's my mass? Subtract, what's my number? So I get what? And you can use a calculator. I don't expect you to do the math in your head, but you get 16 when you subtract. Questions? Questions about how I did that? Want to do another one? Yes? We're going to do one anyways. All right. Fe with a 56 and a 26. What's the mass? 56. That's right, because it's the big number. All right. What's the atomic number? 26. All right. How many protons would there be? I'm not interested. Okay, that's good. I'm glad. All right, there's how many? How do we find protons? Well, we just write down. Protons are the what? All right, they're the atomic number. Okay, so the atomic number is what? 26. Okay, so there's 26 protons. All right, how do we find electrons? 26. All right, they're the same as the what? They're the same as the protons. There's 26. All right, and to do the neutrons, we say mass minus what? So there would be 56 minus 26, which is 30. Are we okay with that? Sarah, what do you think? Think okay? Chase, what about you? Okay? All right, so let's try a different kind of notation. It's the second way you're going to get it. All right, this is called hyphen notation. Now, I like this notation because it's a whole lot easier to type. The downfall is you get how many numbers? One. Now, you can either have it with the full name written out and it says carbon-12, or sometimes, you rarely see this, but sometimes you will, they can just use the element symbol like C-12. Okay? Most of the time it's going to be carbon-12. But sometimes they will write the symbol of the element. That's 3. I give you too many or not enough. What do you think? Here. time, you have how many numbers? So the question is, which number did I give you? Did I give you mass or number? I gave you the mass, okay? Mass has to be given, all right? Because mass changes. Mass does not always have to be the same. Atomic number never changes. It's always the same, so you can always look it up, okay? So we're going to look up the atomic number on the periodic table. So you're going to simply look on your chart and find out the atomic number for carbon, and it's what? 6. So now you have the same information that you had in the last 2 sample questions. Okay? So how many protons does carbon have? Okay? The atomic number is what? It's 6. The electrons are what? 6, because it's still the same as the protons, so it's 6. And to do your neutrons, you do what? So it's mass, subtract number, so you get 12 minus 6, which is 6. And I understand that bothers some of you, but that's just, carbon just works that way. It's just what it is. I can't fix it. It's just what carbon works out to be. That's just graphite. Okay, maybe that's the reason it's black when it's, in a pencil. I don't know. It's a sign of the devil. I can't fix it for you. All right. Let me see before we do this real quick. I think I have this in. I think I do. Let me pull it up and see if I do. Put it in my plans, but I didn't double check myself like a doofus. So let me see if I do have it. Because I'm super prepared that way.
Pardon the interruption. Work keys testing has completed for the day. The seniors have been dismissed. Those that have had second lunch are on their way to second lunch since it starts in a minute. So if you have third lunch, are on their way back to third period. Thank you.
I do have what I want, so we're going to use it in a minute. All right. So I want to do those 3, and then we're going to get the computers and do some practice on class flow 2. Because more practice will help us than less. All right, so we're finding protons, neutrons, and electrons. All right. And if you want, put your name on your periodic table so that it doesn't get lost, or if it does get lost, I can get it back to you. We done?
Yeah.
All right, I left the pen up there. So let me have, oh, I don't know, Raul. Go write the answers up there for the first one. Back my food. Here, okay. Did you do it?
No.
And why not? Go sit down. Give me somebody who did it.
I did it.
I don't want you. I want somebody who doesn't normally participate. Sacramento, what about you? You got it? Go up there and do it. I do not want to stand here and wait on a bunch of people who didn't do it to do it at the board. Sure. Ready to volunteer tonight. Okay. Good. All right, Jania's going to do the second one. Good. All right, and the last one, how about Sierra? You feel like it?
Yeah.
Huh? She didn't take paper. You usually Sierra take that paper? I'm sorry, Jania take her paper? I just had issues with Raul standing at the board working the whole question because he hadn't done it. Good. All right, so how do we feel about that? Feel good about it? Yeah? All right. We're going to practice some on class flow a little bit. Now, no, we're just going to do some where we go backwards now. It's not hard, it's just backwards. All right, so now we want to find atomic number, atomic mass, and both notations given protons, neutrons, and electrons, okay? So now I'm going to give you the protons, the neutrons, and electrons, and we want to find the notations, okay? So I'm going to give you this. I don't need that. I can get rid of that. To write down the question. And then we're going to find the notations. Like we're going to write either nuclear symbol or hyphen notation. We can do it either way, but we want to write the notations. So the things we want to be able to find when you finish this is we want to be able to find the atomic number, the atomic mass, and we want to be able to write the notations. Okay? Whereas before I gave you mass and number, now you're going to find those. Hello, my dear. What can we do for you today? Oh, I thought she was going to need them again tomorrow. I didn't think she'd bring them back today. Here, I'll just set them over there in the box because I'm sure she's going to want them again tomorrow. Or I'll leave my box and give you guys. Damien, you'll be thrilled to know that first period I had no idea how many calculators I had at the end of class because I'd given away 10, so I didn't know how many I had. All right, do we have it written down? All right, so tell me what we know. Given we have 27 protons.
It's cobalt. No.
It's what? I didn't say you were wrong. I just asked it.
Is it cobalt?
Okay, so tell me how you know it was cobalt.
Because I took the 27 and the 27 is even, that's the number. And then I was like,
Okay, so hold on. So you knew it was the what?
The what is it? The number, right?
Okay, so looking at this right here. All right. All right. So Bree's already told us that the atomic number is 27. Okay? Are we okay with how Bree got the atomic number? Because we knew the protons are 27. Bree knew the atomic number is 27. That right there is working backwards. Okay? I didn't give you the atomic number, but because you knew the protons are 27, you knew the atomic number is 27. Are we okay with that connection? Alexis, you with me on that? Okay. Now, what other connection did Bree make about the element from knowing the atomic number was 27? She didn't make that connection yet. She looked at her periodic table and she found the what? She found the element. So she looked up here on her, well actually she looked at her orange, but I'm just looking up here. Okay? She looked up here and she found element 27 and she said it's what element? Cobalt. Okay? Everybody see how she did that? Alright, so cobalt. Or you can write it as big C, little o. Now, if you write it as CO, what does that mean versus that? That means carbon because it's a capital C, big C. Big O means what element? Oxygen, okay? So big C, little o is cobalt. So you can write it either way. All right, what else do we know? All right, how are we going to get atomic mass? Okay, now, this is usually where people get a little lost. All right, atomic mass, and I'm going to cruise back to the definition for a second. Okay? All right, all the way back to atomic mass's definition. What does atomic mass's definition say? Protons and neutrons. Tell me what and means in math class. It means add. Okay? So, if I cruise back to where we were, atomic mass is defined as protons and neutrons. So, how many protons did we have? You said and means plus, and neutrons is what? So, when you add those together, you get what? 59. Okay? Now we have our atomic mass. Now, we can figure out the electrons. How many electrons are there? 27. Okay, so the electrons equals 27. Do we need to know the electrons, though, to write the notations? No, because that's not in our notations. But it's okay if you figured out the electrons. That's cool. All right? So, which notation do we want to write first? Since we got to do both. You want to do hyphen or you want to do the nuclear symbol? All right, hyphen. All right, so if we do hyphen, Alizé said, what's the name of the element? So we write out cobalt. We put a hyphen. All right, what comes behind the hyphen? All right, what came behind the hyphen? Did I have mass behind the hyphen, or did I have number behind the hyphen? I have mass. So now go back to your question. And what do I have up here that y'all found as the mass? What up here was the mass? 59 was the mass. 32 is the neutrons. You got to have the full mass. And 59 is the mass. So cobalt hyphen 59. All right. The next one is the nuclear symbol notation. So that one we'll do as CO. And what goes at the top? The mass or the number? Mass goes at the top. And what goes at the bottom? The number, which is what? 27. Now, I will tell you this. If you flip those and you have 27 at the top and 59 at the bottom, I won't mark it wrong. As long as you have the numbers correct and they're just flipped, I won't mark that wrong. Okay? I'll give you credit.
But what's the thing we saw earlier where it had like the number of?
That's called nuclear symbol notation. Where you had this.
Yeah.
That's called nuclear symbol notation. That's what we just did. Okay, so if you had that and you like put 15 at the top and 31 at the bottom, I wouldn't mark that wrong. Okay? So y'all wrote 27 at the bottom and 59. All right, let's do this one. Same thing. Let's figure out how to write the notations. What do we know? What can we figure out from it? Guess what? Tell me something we know. What'd you say?
It's sulfur though.
Protons are 16. All right, John. All right, John said the protons are 16. All right, how'd you know it was sulfur?
Since the protons is a set, the protons being the atomic number, and I looked for the atomic number. And
all right, so the atomic number is what then?
16.
All right, so the atomic number equals 16. And so if the atomic number is 16, you know the element is what? All right. Now, all of these leaps that you guys just made are all the same. So, you knew the protons and the electrons have to be equal. So the protons are 16. The atomic number is 16. So the element is sulfur. Okay? All of those things are interconnected. Is everybody okay with that? Okay. Now, the last piece you need is the what? It's the last thing we need to find. You need to find the what? I heard it. The mass. We need to find the atomic mass. Okay, so how do we find atomic mass? You got to add the protons and the neutrons. So how many protons did you say there are? 16. Plus, how many neutrons? 18. Okay? We're going to talk about this. It's called an isotope. They're not always going to match. What is the number I told you had to match? The atomic number has to match. The atomic mass does not have to match. And it's not going to always match. Okay? All right. So, hyphen notation. What element are we? Hyphen, what mass? 34. All right, next. Big S. What goes at the top? 34. What goes at the bottom? Think you can try one? Yeah? Okay. Don't want it. I don't want it either. Apparently I got work backwards for everything except what I want. All right, so let me just create some of my own here. Let's say that we have 22 protons and I grab a periodic table. Five neutrons. And let's say we have 33 electrons and oh, I don't know, 45 neutrons. All right, write them in both notations. See what you can do. Yes, ma'am. Huh? Okay, so when you look in your periodic table, okay, you're always looking based on the atomic number or the protons. So when you figure out that it's got 16 electrons, plug it in, and you know your electrons are the same as your protons, 16, you look for the low number. You find the low number, that's 16, and then we'll have 16. Okay, so like the last one is the low number of 27. So you find the low number of 27. And then so that's it. Okay. Who else has a question? Anybody else? Are you trying something this time around? Yeah, I agree. That's what we will see. That's all. What is arsenic? It's actually an alloy. It's used as it's not really a really heavy metal, but they use it in ant killers. Probably the thing that most people know about it, and people have used it to poison people. The nice thing about it is it can be used to poison people in a way that it mimics symptoms, so people just get sick. And sometimes it's hard to diagnose initially, but once doctors suspect that it's arsenic poisoning, it's very easy to test for, and then easy to trace back to whoever did it to you. If, for example, Blanche Taylor Moore, who used to be on death row, I don't know if she's died yet, but she poisoned either 3 or 4 spouses with arsenic poisoning, and they went back and dug them up and tested for it. So she's on death row until she dies. I don't know if she's died yet, but she's known as Blanche Widow. She killed 3 of her spouses with arsenic.
That's great.
So like I said, it's easy to check for that, but they largely use it in insect killers. Like ant poison. Yeah.
So isn't that thing where they like pour it in there and then the whole thing turns into milk and just take the ant killer out?
That I don't know. I've never actually used it.
I saw someone do it.
You can go on mine. Yes, except put pipe in there instead of coal. Good. All right, who else? Anybody else? Yeah. That's it, you missed. Do the next one. What you got? There you lost. Atomic numbers, good. So find the element that goes with 22. See, you got atomic number 22. So find the element that goes with that. Who's got the 22?
Some of these don't even match that word.
I'm gonna have a couple new. Yeah. Yeah, Chase. All right, we're at. Okay. Huh? All right, so we're at. So how many electrons do you have? Can you tell me that? Huh? Okay, that's something. Can you tell me the atomic number? Okay, you're not as lost as you think you are. You at least got those two. All right, so atomic number is 22. Can you tell me the element that goes with it? Or tell me how to find the element that goes with it? Yeah, right, titanium. All right, so now we just need the mass and we can write the notation. We're half the way there. How do you find mass? Yeah. Yeah, it's lost as you think you are. Huh? No, mass you have to find. So what two things make up the mass? Okay, so now we need to write the two notations. The one that's the hyphen notation, you write the symbol all the way out. You're going to write the word titanium. Hold on. What goes with 22? This one, and you're on the side. Okay, and then put a hyphen. And what goes behind the hyphen? The mass or the number? The mass. So what mass did you just get? You put 47. All right, now the one that has the symbol, you write the symbol for titanium, which is, you write Ti. And then you use both numbers. Okay? And then what was your atomic number? There you go. Oh. Okay, so try the other one. You got a question?
Yes.
All right, hang on. All right, so how do you get the atomic mass?
This is the easiest. This probably the easiest one we're gonna do in this like the yard.
That don't get hard, except that we gotta add in ions.
See, that's hard.
Just as a word technique, I mean, it's hard. What two particles make up the mass? So what do you do with those two numbers? Yeah, 22 plus 25.
Oh,
Okay, so that's your mass. So label that as your mass. We write out the atomic mass equal if I make sure. Okay, so now we've got everything we need. So we're ready to write our notations. So if we do hyphen notation, we do it like this. So we don't write equals, we make it a hyphen. Okay, so what was our element? So write titanium. Hyphen. Dash. No, not slash, dash. All right, then what's your mass? Yep. Okay. Now, so here it is. Now we're going to do the other one. So what's the symbol for titanium? So write Ti. Okay, let's say. And then what's your atomic number? Yeah. And the other one. Yes. Those two. Yes. All right, what's your question? That's your. What's that? It says 47. You wrote 45. Okay, you need a atomic number now. Yeah, let's see. Put the first one for me.
Can I do the second one?
We're in. We'll do it.
What is that? I can do the first one. So you can
I already asked them to see it. Yeah. So right, that's the atomic number. Just like you labeled yellow at the top of mass. gotta write this, now you gotta write the notations. So it looks like this, and you write the other one down. So what element is, there's your periodic table up there. Alright, are we looking up the 47 or the 22? Always look up the atomic number. So look up the element that's got 22. Hold up. The AS 7833, right? You got the hydrogen. Who has 22 on here? Yes, you're right. Okay. Hyphen. Like that. Oh. Go down all day, wait. Okay, so you're doing the one that's got a symbol. All right, instead of writing out the word. It depends on which one you're doing. Are we doing the symbol one or the word one?
The word.
Okay, then write out the word. Go ahead. That was killing. Okay, so after the word, put a hyphen. Dash.
Oh, yellow, because that's a pretty color.
You people have been paying attention all day. A hyphen, I've had slash, I've had commas, I've had colons. A hyphen is that. Now you put your mass behind the hyphen.
That would be. Why turn red? No.
Just go up there and erase and touch the yellow again. Erase with your hand and touch the yellow.
Okay, there we go.
Amari, why are you here?
I'm saying,
Hey, Amari, go back to lunch.
So that'd be 47.
I'm just enjoying the peace and quiet.
just let the kids on you. Just
Now I combine the two questions. That was one question. Now, somewhere else, the other question. Now, but you're going to use 7. Only 2 with it somewhere else. There's 2 separate questions. Okay. Yes, AS.
Let me go check my thing first. Oh, we're supposed to be A.
Yeah, that's AS. Why are you putting titanium on both of
Because
them?
I was looking at that one.
Yeah.
Can
you tell the difference between what class and this class? Really?
Okay.
Yeah. You wonder why.
I got it
this
now.
is your class.
She told you it was right.
I told you it was right. You just only did one answer. I said you had to do the hyphen notation. So this is that first one. Now you gotta write out arsenic hyphen and put your mass behind it. Where? Oh, I didn't see that down there. Sorry. Your handwriting's a little rough there.
Hey, I got that right, man. Oh, I forgot you were recording the class. My face is all in the camera.
Why do they
That
have
is
what?
so embarrassing.
Oh, because they're estimated averages or estimated masses because they're radioactive elements. What is it with that phone?
My bad.
Put that thing on silent. All right, we got it? Yes? All right. You want to do class flow or keep going? Keep going. All right, fabulous. I would rather keep going. I think class flow is slow, but I was trying to entertain you. All right, so y'all keep asking me about why the numbers on the periodic table are different from the numbers we're using, okay? The reason for that is a word you might remember from middle school. Did any of you remember hearing the word isotope? Somewhat? Okay. A lot of people remember the word isotope, but they have absolutely no idea what the word isotope means. Okay? It's okay. All right? An isotope, okay, we got to get rid of this yellow here. It's a pretty color, but nobody can see it. All right? Means you have an atom with the same number of protons, but a different number of neutrons. Now, I left little parentheses there because I'm going to come back and insert something there. All right, an isotope is an atom with the same number of protons, but a different number of neutrons. So, what is another word we've learned today that means the same thing as an atom with the same number of protons? What's a proton? Another word for proton we've learned today. What's the number of protons? Atomic number. Okay? So you could have the same atomic number, all right, but a different number of neutrons. What makes up the neutrons today? The atomic mass. But you could have a different atomic mass. Okay? So if you have the same number of protons or atomic number, but you have a different atomic mass, then you're an isotope. So, what are some examples of that? Here's an easy one for us to talk about. Carbon 12 and carbon 14. Well, you go ahead and close the door. I don't want to listen to it now. All right, carbon 12, we all use if we're writing with a pencil. Okay? Carbon 12, all right, carbon 12 is graphite. Even though y'all argue with me regularly that you're writing with a lead pencil, you're really not. You're writing with graphite. You're writing with carbon. Okay? Now, carbon 14 is used for radioactive dating for fossils, rocks, like when they want to know how old the Grand Canyon is, or some dinosaur bones. We use carbon 14 to see how old it is. Okay? Now, I think we can agree that carbon 14 and carbon 12 are not the same thing, right?
Yes.
One's radioactive. You want to write with radioactive pencils?
Yes.
Yes.
Well, I guess we could, but most of us don't want to be exposed to too much radiation. So, we just generally don't work with carbon 12 and carbon 14. So, what things do they have in common? Well, if this is their mass, y'all put that phone on silent. Y'all are wearing on my nerves today with that. Mine's not dinging every time I get a message or an email. Put y'all's on silent. All right? How do you get the atomic number? Where do we get the atomic number from? Where do we get atomic number from? We get it from the protons. Where do we find the protons at, Janai? It was not given to us. Where did we find it just a minute ago when it wasn't given to us? Be a number, and we find the number where? Where'd you find the number when it wasn't given to you just a minute ago? Yes, you touched it. What do you say out loud then? What's that called? The periodic table. Okay? So we look on the periodic table and we find the atomic number. Everybody with her on that? So what's the atomic number for carbon on the periodic table? 6. Okay? So the atomic number is 6. The atomic number is 6. So how many protons do we have? We have 6. Protons over here would be 6. How many electrons would there be? How many electrons would there be? Electrons?
Wait, you said 14.
They're 6. The protons and the electrons are what?
So electrons.
No, I said electrons. The electrons and the protons are what? 6, because they have to be the same. Now, for neutrons, we do what? That's when we subtract. So we get 12 minus 6, which is 6. And over here, we get what? 14 minus 6, which is 8. Now, that's what makes an isotope. The fact that the protons are the same, but the neutrons are different. Does that make sense? Protons are the same, neutrons are different. Ready, stay off that phone or I'm going to have it. Now, how does that impact us, other than knowing the definition? This is the way it does. Everybody have what they want? So if I give you iron-58, okay? I want you to look up iron on your periodic table. Because notice the question I asked. What mass do we use? What mass is on your periodic table? 55.85. So most of us would say 55 is the same as what? Okay, it says 55.85. Most of y'all would assume that's what? 56. So, are we going to use 56 or 58? Which one are we going to use? The one I gave you or the one that's on that periodic table? That's right. All right, you use the one I gave you. I need more space. You're going to use the 58, the one I gave you. Okay? You're not going to use the 55.85 that rounds to 56 on the periodic table. All right? The reason is the number that's on the periodic table is an average. It's a lot like grades. All right? Right now, I think you're supposed to get a progress report today, 4th period. I know they're supposed to be printing them here sometime early this week to hand out. All right? Right now, you have a grade, and Ms. Glass is going to print and hand out on a progress report. It's how many grades? How many grades will be on that progress report? 4. 1 for each class, right? So besides, well, how many classes do you have? But for physical science, how many grades will be beside your physical science grade? 1. Yes, but for this quarter, there will be how many grades? Just 1 for this quarter. It doesn't matter right now that you have 25 grades. Can I put all 25 grades on my progress report? No, it will be 1 grade. Okay? It's an average, so you get 1 grade. So let's say that iron has 5 isotopes. 5. How many numbers are going on the periodic table? 1. Okay? So that number that's on the periodic table is a what? It's an average of all the isotopes. 58, is that an average? No, that is one particular isotope they want you to use. Do you use the number that's in the question? Does that make sense? Okay? But 55.85 is an average. You use whatever number's in the question. So when you go solve, you just use what I gave you. All right? So we use the 58. So when you go to solve, how do you find the protons? What do you do to find protons? What did we do just a few minutes ago? What's the atomic number? So the atomic number is 26. How many electrons are there? How do we find the neutrons? 58 minus 26, which is what? 32? All right, I'm not doing ions today. All right, we're going to practice. We'll see what we can do here. We're going to change it up a little bit. Let's see what we can do. I'm going to do the first row. Might even do a different row with you. And then y'all are going to fill in the rest of the chart. I'm going to put Logan and Raul.
Oh, man.
With Roy and William. One for Caleb, although he might need some help. All right, this one for all four of y'all. And you will have a quiz Tuesday, Thursday. It's going to look just like this. Chart format and all. All right, which row you want me to do?
Okay.
All right, the first one's kind of easy. Let's do the second row. All right, so all you know is the atomic number and the number of neutrons. Okay? First row I even gave you the symbol. That's why I said that was kind of easy. All right, so the second row, you only have the atomic number and the number of neutrons. So if you know the atomic number, what else do you know? All right, so what are the protons? All right, so the protons are 12. All right, what else do you know? What'd you say, Sierra? What are the electrons? Very good. Okay. What else do we know? Come on, dudes. This is what we were doing when we were working backwards. Frontwards and backwards. We know the what? We can find the mass. That's not hard, but I was thinking symbol and substance might be a whole lot easier.
Oh,
All right, how'd you know it was Mg?
because 12.
Because 12 tells you to look up the element on the periodic table, which is what? Magnesium. So you're going to find that it's magnesium. So you're going to write magnesium here. And its symbol is Mg. Okay? So we got those two. Now how are we going to find the mass? You cannot look it up on the periodic table and write 24.3. That crap is wrong. You're going to do what, John? Add what? You're going to say protons plus the what? Plus the neutrons. So protons plus neutrons is what? 24. Everybody got it?
Mm-hmm.
All right. You must do from here to here. Got to do those rows. Okay? Because some of us are not going to finish before the bell. This is 1:15. The bell should be back on. Okay? But those have to be done before you return to me tomorrow. It's only 5 little rows. That should not be overly taxing. Let's scan that. I'm going to put it on the website.